For topic 3, we're going to be solving radical equations containing square roots again, but this time we're going to have just a single extraneous solution. So don't confuse that necessarily with what happened in the last video. In the last video, we had no solution at all. Here, we're likely to have a solution, but maybe when we solve, we get two solutions and one of them does not work, but the other one does. Okay? So just recall, I already reminded you of this at the beginning of the video, or at the beginning of the worksheet rather, but an extraneous solution is a solution that is obtained through the solving process that does not satisfy the equation. So when you're dealing with radical equations that have an even index, so for us, we're just going to do square roots. But when you're dealing with an equation that contains a square root, you must check your solutions. Okay. And this is going to be a real good reason why. Okay. So the directions here again, just say solve the equation and check the solutions. So let's get started. Remember, our goal is to isolate the radical, square both sides, that'll undo the radical, and then solve the resulting equation, okay? So we've got the square root of x plus 5 equals x plus 1. So we've already got the radical isolated. Let's go ahead and square both sides. So we want to take x plus, or the square root of x plus 5 and square it. Then we want to take x minus 1 and square that, okay? So you're going to have to do a little bit of work here. It's going to be maybe a bit more complicated, a little bit more involved than the previous videos. Okay, when I square a square root, remember, we're just left with the radicand. So on the left, I just have x plus 5. That side's easy. On the right, x minus 1 squared is really x minus 1 times itself. Okay, so we have to do the FOIL method here. So I'm just going to rewrite my left-hand side, and then I'm going to FOIL my right-hand side. So let's see, I get x times x, which is x squared. I get x times negative 1, which is negative x. Negative 1 times x is negative x, and negative 1 times negative 1 is plus 1. So we simplify again. We get x squared minus 2x plus 1 on the right, okay? Now, you can see we clearly have something that is quadratic in nature, so you have to kind of go back to when we talked about quadratic equations. We talked about solving quadratic equations by factoring, and what we had to do is we had to get the equation in what was called standard form. So standard form for a quadratic is the squared term, the linear term, the constant, and then equal to 0. And you always want to set this in such a way that the squared term stays positive. It just makes life easier for us, okay? So I'm going to subtract an x, and then I'm going to subtract a 5. So x minus x is 0. 5 minus 5 is 0, so my left-hand side is 0, which is good. And then on the right-hand side, I have an x squared. Then I have negative 2x minus x, so that's negative 3x. And then I have 1 minus 5, which is negative 4. Okay? So we have to factor, and you have to kind of remember how to factor a quadratic trinomial where the coefficient of the squared term is 1. Okay, this is the kind of easy shortcut factoring. So we can jump straight to two binomials. Each starts with a factor of x, so that when we take the first term as a factor of x, so we get x times x, that gives us our x squared. Now we need to find factors of negative 4 that have a sum of negative 3. So we could use negative 4 and 1, 4 and negative 1, or 2 and negative 2. So of those three pairs of factors, which pair adds to negative 3? This one. So we want to fill in a negative 4 and a plus 1. And now we can apply the zero product principle or the zero product property, okay? So when you have a product equaling 0, take each factor and set it equal to 0 and then solve. So I've got x minus 4 equals 0 and x plus 1 equals 0. Well, these are pretty easy to solve. For the first one, I just add 4 to both sides. And that gives me that x is equal to 4. On the second one, I just need to subtract 1 from both sides. So that just gives me x equals negative 1. But I have to check my answers. Okay, you have to. So let's check x equals 4. Well, I go back to my original equation. Anywhere I see an x, I plug in a 4. So I get the square root of 4 plus 5, which is the square root of 9. And that equals 4 minus 1, which is 3. Well, the principal square root of 9 is 3, so 3 equals 3. We're good. X equals 4 works. Now let's check x equals negative 1. So anywhere you see an x, you're going to plug in a negative 1. Well, here you can see that something's going to fall apart because we're going to have a principal square root equaling a negative. So we get the square root of 4 equals negative 2. But remember, principal square root, a and b have to be positive, or they have to be non-negative. So this can't happen. 2, the principal square root of 4, does not equal negative 2. So this puppy right here is extraneous. And if you have a solution that is extraneous, it cannot be included in your final answer. So our final answer is just 4. -1, we obtained it beautifully during the solving process, but it just simply did not satisfy the equation, okay? So be on the lookout for situations like this. You have two solutions, but maybe one of them works, the other does not. Hold tight. My dog is losing her mind right now, so let me pause. Okay, so let's go back to the worksheet and look at example 3, part B. Okay, so remember, we could potentially have a solution that doesn't satisfy the equation, okay? Oh my God, the dog, she's killing me today. Hold on. Okay, she's outside. So let's go back to the worksheet. Okay, so remember, we're in a situation where we could have an extraneous solution. That means when we solve, the solution may or may not satisfy the equation. And in this case, we're going to get two solutions when we solve. And it just so happens one of them is probably not going to satisfy the equation. So let's solve. Remember, the steps are to isolate the radical. In part B, the radical is already on its own. So we want to square both sides of the equation. And when we do that, we're going to see that we get something quadratic in nature. So I've got the square root of 3x minus 11 squared, and then I've got x minus 5 squared. Well, the left-hand side is easy. The square root and the exponent of 2 unravel each other. So I'm left with just 3x minus 11. On the right, I have x minus 5 times itself. So let's FOIL. When you have x minus 5 squared, there is a shortcut to the foiling. If you know the shortcut, take it. If you're just don't remember it from when we talked about that chapters ago, just do the full FOIL method. So x times x is x squared. X times -5 is -5x. -5 times x is -5x. And -5 times -5 is 25. So we simplify, and we get x squared minus 10x plus 25. We definitely have something quadratic in nature, so we want to put this in standard form. Remember that from part A. That means I need to subtract a 3x and add an 11. And I'm going to do this to both sides. Okay, well, 3x minus 3x is 0. -11 plus 11 is 0. So we get that 0 on the left, which is great. That's what we want. And then on the right, we get x squared minus 13x. -10x minus 3x is -13x. And then 25 plus 11 is 36. So we need factors of 36, either both positive or both negative, that have a sum of -13. And think about this. If we need a sum of -13 and our factors need to be the same sign, in this case, to get that negative sum, they both need to be negative. So let's see. We could have -36 and -1. That doesn't work. We could have -18 and -2. That does not work. We could have -12 and -3. Doesn't work. We could have -9 and -4. I like that one. That works. So that's our pair of factors. So -9 times -4 adds to, or multiplies to give me positive 36, and then it adds to give me the -13. So we start factoring. Luckily, the coefficient on the square term is just 1, so we can jump straight to two binomials, each starting with an x. And then I want to go minus 9 and -4. Okay, now we can apply the zero product principle. We can do this when we have a product that equals 0. You take each product, or each factor of the product rather, and set it equal to 0. So if I have x minus 9 equals 0, I want to add 9 to both sides. That tells me that x is equal to 9. If I have x minus 4 equal to 0, I want to add 4 to both sides. So I get x equals 4. So x equals 9 and x equals 4. Let's see. Let's check. So anywhere I see an x, I'm going to plug in a 9. So I've got the square root of 3 times 9 minus 11 equals 9 minus 5. Well, let's see here. 3 times 9 is 27. 27, oh, that's a 7, I promise. 27 minus 11 is what, 16? 9 minus 5 is 4, and the principal square root of 16 is 4. So 4 does equal 4, so we're good. So x equals 9 is fine. Let's check x equals 4. So we rewrite the equation. Anywhere we see an x, we plug in a 4. So 3 times 4 minus 11 equals 11 minus 5. Let's see, 3 times 4 is 12. Oh, wait, don't do that. That's not 11 minus 5. It's 4 minus 5. So we get 4 minus 5. I'm not sure why I said 11. So 4 minus 5. So let's see. 3 times 4 is 12. 12 minus 11 is just 1. So we get the square root of 1. 4 minus 5 is negative 1. And right here, you should be like, nope, this can't happen because you cannot have a principal square root equaling a negative. When you have a principal square root, both a and b, the radicand and the result, have to be non-negative. So this already is not going to work. So we get the square root of 1 is negative 1. Well, the principal square root of 1 is 1. 1 does not equal negative 1. So we would have to come down here and say 4. This is extraneous. All right, so our final solution is just x equals 9. Okay, so be on the lookout for those. When you have an even index, you really must check your solution always when you're solving these radical equations. Whoops.